Okay, so in the last video we spoke about microkernels and monolithic kernels. Now, there are two types of services that are present on an operating system. One is called the user services, while the other is called the kernel services. Now, the kernel services are much more services that that passes instructions directly to the hardware, to the computer hardware. While user services passes instructions directly to application programs and peripheral programs. Now, these two service types of services, both the user services and the kernel services, reside on the operating system. And that is what actually differentiates microkernel from monolithic kernels. In microkernels, user services and kernel services are in different address space. Now, that you see the diagram of that scenario. Now, this makes the size of the microkernel to be smaller than that of the monolithic kernel, because of course they are in different address spaces. In order for a user to use a kernel service, message passing is used. So now, if a user service wants to use a kernel service or a kernel service wants to use a server service, both two services pass messages between themselves. Now, this makes the execution of microkernel to be slower because there has to be an exchange between both of them since they are not in the same address space. Now, the microkernel is easily extendable because, of course, that is understandable because it uses a different address space. Because if you need to add any extend it, you can easily just isolate that aspect and extend it as you would want to. If a new service has to be added, then it will not require any changes to the kernel itself. Also, if any user services crashes, it does not affect the working of the microkernel. Some examples of kernels of operating systems that use microkernels include the Kernels, the Minix, Symbian. Hope you guys have not forgotten the Symbian mobile operating system that was introduced some time ago by Nokia. That was before Microsoft bought Nokia, and Nokia now became a Microsoft operating system, mobile operating system now became the main operating system used by Nokia. Initially, Nokia had their own mobile operating system called the Symbian. Then Microsoft operating system X, Alpha Linux, Integrity, and K42 are examples of operating systems that use microkernels. Then monolithic kernels, of course, will be an opposite of the microkernels. A monolithic kernel is a kind of operating system in which kernel services and user services are present in the same address space. In order for a user service to use a kernel service, system call is. Don't forget that in microkernels, if user service and kernel service wants to communicate, they use message passing. Now, this time around, instead of using message services, use system call. In both situations, it's good to mention that in both microkernels and monolithic kernels, on every type of system, there's always a set of instructions called the system call. These system calls are have authoritative control over the system. These system calls are how your computer operates actually. Anything that has to do with the system, a call is initiated. Now, look now, instead of now passing messages, the authoritative instructions for the system, which are called the system calls, are used in monolithic kernels. Now, this makes the execution of the monolithic kernel much more faster than the microkernel, obviously, since they are using the authoritative instructions for the system calls. Also, the size of the monolithic kernel is much larger than that of the microkernel. By extension, the size of the operating system is larger. Obviously, that's because the user services and the kernel services are being matched together. Therefore, there will be an increase in the size of the operating system and the kernel by extension. Monolithic kernel is not easily extendable, obviously, because both the user services and kernel services use the same address space. Because the user services and kernel are present in the same. Okay, that's what I said just. So in order to add any service, changes have to be made to the entire kernel itself. And you then see that even though this is faster, it is much more complex to update and to add. While microkernels are much more slower than monolithic kernel. Not that they'll be very, very slow like that, but comparatively, they'll be slower than the monolithic kernel. But making updates and extending is quite actually faster in microkernels. And yes, in microkernels. Now, the major drawback of monolithic kernel is that if real service crashes, it may crash the whole system, since obviously again it uses the same address space. Now, a diagram of the monolithic kernel and the microkernel is given. Now, you can see for the microkernel, you can see that the user services, these are the user services, and these are the kernel services, use different address space. You can see device file servers, Unix server, application IPC, all are different. Now, this is the computer hardware. Now, if you compare the monolithic kernel, everything, both the user space and the kernel space, are on the same address space. Now, the application is on top of the two. So, if you need to extend this, you have to edit this entire kernel. While for the microkernel, don't forget that from here to here is a kernel. So you can easily add another block of application just on top here, and your kernel is still going to work fine. Okay. So that's the end of the class today. We'll meet in this discussion, and you guys can then ask any questions that you have. Thank you.